We are going to explore the question, how do exponents affect how we combine like terms? We're going to use the model at the top, which represents a numerical expression, and then we're going to apply what we learned from that to the algebraic expression that we're going to create on the bottom of the page. All right, let's start with the simple model. Here we see 4, and we have 4 groups like that. So in other words, 4 groups of 4. All right, now we're adding to that 2 of these, 2 of whatever we're calling this thing. Now, if this is 4, isn't this 4 squared? It's 1, 2, 3, 4 by 1, 2, 3, 4. 4 squared, 2 of those. And we're adding to that, we have 3 groups of these. And now let's think about what we might call these. These are cubes, right? So they're cubic units. And isn't this 4 cubed? 4 cubed. This is a numerical expression that fits the model that you see here at the top. Now let's apply what we know from this to an algebraic situation where we're using variables. Now in this case, we knew that this was equal to 4, but let's say we don't know what it's equal to. It's some number, but we can still tell that we have 4 of them. So let's say we're going to use the value n to represent the number, or x or something like that, but let's stick with n. Now here we have 2 groups, and if this represents n, see it's the same dimension, and it's a square, that would be n squared. So if this is n squared. And then we're going to be adding to that, we have 3 groups of these, and these are cubic units, so that's n cubed. And again, just so that you can see why it's equal in size. It's a little bit hard to see that, but you can see that the front of that cube has the same dimensions as this square, so we're not changing. The length of this edge would represent the length of this, and the length of this, they're all equivalent. So this would be an expression, an algebraic expression, that fits the model here. Now remember, the value for n could be any value. For example, let's say we know that this is 5, then this would be 5 times 5, or 25, and this would be 5 times 5 times 5, which would be 125, and we could simplify that. Or it might be another number. It might be the number 6. But whatever the number is, it's the same number. All right, now the next thing I want to point out, since we just have a couple of minutes, we could have these organized in a different way. If I move these around a little bit. And it would still be equal to this expression, by the way, that I have written here. So let's take a look at how that might look. Now in this case, we would have 2 of the n cubed plus 2 of the n's plus 1 of the cubes, so that's a cubic n, and then we have 2 of these plus 2 of the n squared, that takes care of these 2, and then plus 2 of the n's, 2 n's. So this is the unsimplified version of what we're just looking at. We've just kind of moved everything around. If we were going to go back and combine like terms, you would take the terms that all have the same exponent. So for example, here we have 2n, here we have 2n, and that would get you back to the 4n that we started out with. Here we have an n cubed, and here we have 2. Remember, there's a 1 in front of that. And here we have 2 of the n cubed, so that would be 3n cubed if you were to combine these two. And then what we have left is 2 of the n squared, so that's kind of already in simplest form. 2 of those, and it brings you back to what it looked like before. All right, hopefully you understand exponents a little bit better, and you can see why we can't combine a squared with a cubed. Hope you found this helpful.